Hello grade 12s. Today I am working through a past paper 2 IEB exam, preparing myself for the exams to come and familiarizing myself with the type of questions they ask in the IEB paper. In 2018 a new examiner took over paper 2, and we've seen since 2018 they have only asked one question, the CAM, for the Loci section. So that does mean there are more marks allocated to your displacement graph, which means you need to know all the different types of motion, which you should do anyway. That is uniform motion, simple harmonic motion, and uniform and acceleration and retardation. So you need to expect that those will all come up, and when you analyze the papers, the 2018, 2019 and 2020 papers only had a CAM. So if you can complete these drawings to a suitable standard, you should be well prepared for the CAM section of your Loci. From 21 to 2023 they have started including the mechanism, so that is a topic that you'll also need to know. But if you can complete these, which are the harder CAM questions, you should be able to get the 25 marks that they then ask when they have included the mechanism in the Loci section. Okay, so this is the 2020 past paper, the IEB final paper 2, and we are looking at the CAM. So here is our question paper. They have given us a diagram showing the camshaft, the follower. It's a wedge-ended follower. They've given us part of our displacement graph, given us an area where we need to do some labels. So I like to get marks on the board, so I would look at doing some of the basic things like drawing the follower and hatching the shaft, putting in the labels. So that's going to be my first start. Draw my camshaft and hatch that, draw where my follower is going to be and label that, so I've got some marks already. With this drawing I want to make sure that I'm finished in my allocated time. I'm allocating myself 40 minutes for question 2. This is the only question in question 2, so I don't have to split it up. My start time here is 2:22, so I need to make sure that I'm finished by 3:02. So I have drawn and hatched my camshaft, I've drawn my follower, I've put in my direction of rotation. Now if it's saying it is rotating anti-clockwise, we need to remember that if this was our cam, the first part as it spins, the profile would be this side then. So the first part to come past the follower is coming from the right hand side. So when we label in the opposite direction. The follower is always 0. So there's 0, 30, 60, and label our sides. We might have some extras to do, but at least we get that correct. So super important. This could mess up all of your hard work and effort if you just position this incorrectly. It's saying it's going anti-clockwise, so we label in the opposite direction to the direction of rotation. so we label clockwise. I've done and printed neatly the displacement graph heading. They've already given themselves a mark for the scale. So let's start doing the displacement graph. So from 0 to 60, the follower drops 20. Now I'm assuming that this lines up with the top. Yes, it does. So from 0 to 60, the follower drops 20. So here at 60, I'm marking off 20. And I can join that up to the start point at the top of my graph. Okay, there's a 105. So we need to find 105. 105 will be 4 millimeters across here. Okay, so there is 105. Follower is at rest from 105 to 195. The follower drops 34 with simple harmonic motion. So let's work out those points. 105, 195 will be here. Let's assume that each corner, each division is going to need a half division. So I'm marking those off. And that's 195. Now if I just check this, that would give me 0, 1, 2, 3, 4, 5, 6 divisions. That's great, because that could then match 6 divisions we can do in the circle. Simple harmonic motion implies that we use the circle. So it's saying it's dropping 34. That is to the bottom of the graph. So I want to mark off 17. And draw my semicircle. Again, your circle stencil should be able to help you here. If you've got a circle stencil, get your diameter of 34 and draw so there's my semicircle, and I'll put in my divisions. Now, with your divisions, I generally like to label them in some way or form. So I usually use 0 as my start point and label them like that. Then horizontally the same thing, that was 0, 1, 2, 3, 4, 5, and 6. And then my theory of 2 points. I like to use the theory of 2 points. So for example, this is where vertical line 0 is, as well as horizontal point 0, which gives me that point. Next, this is line 1, so I need to project my horizontal line 1 where it intersects, gives me my point. There's point 2, I project that to intersect my vertical line 2, that gives me line point 2. There's point 1, point 3 as well, where it intersects line 3. That is where point 3 is. Point 4, I projected to intersect vertical line 4, and there is point 4. Point 5, I projected across, find point 5. Point 6 and 6 is that actual point at the bottom. When I join up this graph, my middle 3 points is my check for accuracy, and they should be in a straight line. Then I can come around and hockey stick into the corner. On the other side, my hockey stick going into our first point, and bend around to come into our second point. Now it says from 195 to 240, it's at rest. So there is rest. Then it's saying from 240 to 360, it rises to the original position with uniform acceleration and retardation. Okay, so if we do that, we're at 0 is at 240, 1, 2, 3, 4. That's a round number, so we could use that to find just 2 more points at the acceleration side and 2 at the retardation side. So we've got 4 vertical lines here. So what we need to do is find 4 horizontal lines. Now, the one point when we do uniform acceleration and retardation, the middle point is going to be from diagonal corner to corner. Where it intersects in the middle will give you a middle point. So there would be my middle point. If this point was 0 and 0 here, that's my start point. So I now need to find the center of the space here. Now that distance is 1026, so I'm going to mark off 13, and that would give me height 1. Okay, this was height 0, height 1, height 2, mark up 13, there's height 3, there's height 4. That was vertical line 0, 1, 2, 3, and 4. So when 0 and 0 meet, that gives us point 0, which makes sense. That's where we started. Next, from that corner, we project to height level 1, where it intersects vertical level 1, gives us point 1. There's point 2. Point 3 we're going to find on the other side by projecting from the corner to height level 3, where it intersects vertical line 3, that gives us point 3. These middle 2 lines are a straight line, and then hockey stick into the corner, hockey stick, and there is our graph. Okay, so simple harmonic motion where we use the circle for our height divisions. When we're using uniform acceleration and retardation, it's equal height measurements matching how many horizontal divisions we have. So here we had 4 divisions, so we had 4 height divisions. Even if you don't understand this, please, you should get this point because that was the start point. This point because when we drew the diagonal, that gave us that point, and it gave this point. So there are aspects that you can always get. So don't throw away marks, throw in the towel. You'll have that point, you'll have the middle point, and that one. Much the same with your simple harmonic motion. The middle line would be at the middle height. So you'll always have the start one, you'll always have the middle one, and you'll have the end one. So you can always find some marks. Now it's the wedge-ended follower. Our next step now is going to be to project my heights across and then transfer them to the various points. Always remember, project them to the vertical line, never to the diagonal, because that would change the actual measurement. So we're going to take our heights, project them across. Again, when I'm going to project a couple to show that I'm doing projections. So there was 30, there was 60. Now here I've just made the mark. Now 60 goes to 105 because it was at rest. Okay, let's project that one. That's going to 120. It's going to 135. 150. 175. It's 165, sorry. Here is 180. And 195. Now I need to find those separate little measurements here. So we needed to find 105. So here would be 105. Okay, there's 105. 135. 195. 165. Okay, so now I want to transfer those measurements. So there's 195. 180. 165. 150. 135. Okay, I'm going to project this one. So that's going to 120. This goes from 60 to 105. So here's 105. So this I could actually draw dark because that would actually be our point then. And here is 30. Also show projection on that one. Okay, finish them off. 240 is my lowest point. It's the same as the 195. Here's 270. 300. And 330. Yeah, let's mark those off. There's 330. $300. There's 270. And 240. Okay, there are all my points, and you want to join them up. Remember the idea of a balloon trying to push out, so it generally bulges out. If you've got your French curves or flexi curves, that would also help you draw a nice shape for your graph. And there you've got your CAM profile drawn. Just check, have you done your graph and labeled it? Yes, we've done the label and we've done the graph. We've plotted our points, yes. Do we have the locus there? Yes. Have we done the construction? There's our simple harmonic, there's our uniform acceleration and retardation. Have we done the shaft and hatch that? Yes. Have we done the direction? Yes. And the divisions? Yes. Have we done the follower? Yes. So there's the drawing. I've completed my drawing at 2:45. Which means I have got 17 minutes to spare, which I can then add into some other drawings.